Hello students, welcome back to the channel. Today we are going to start chapter 4, that is atomic structure of class 8 ICSE. In this chapter we'll be seeing a brief introduction followed by atomic models given by 4 important scientists, which is very important for you to know. Then we are going to see the modern atomic theory, the terms related to atom, arrangement of electrons, valency, formation of compounds and conclusion. Today in this video we'll be just covering the introduction and the atomic models because it is a detailed chapter, a very important chapter, so we'll go step by step in order to understand the important concepts. Now coming on to the introduction part, the word atom is a Greek word which means indivisible, because the ultimate particle, indivisible meaning it is an ultimate particle beyond subdivision. Now the concept that all matter consists of extremely small particles was put forth by Indian and Greek philosophers and later by John Dalton. Now we have two views, that is ancient views of the atomic structure. One is Kanad's concept of an atom, where he stated that matter is made up of particles called atoms. He also called those atoms as Paramanus. Then we have Dalton's atomic theory. He gave the main postulates of atomic theory of Dalton is that atoms of the same element are alike and they will differ from the atoms of other element. Then these atoms combine with other atoms in simple whole number ratio to form the compounds. And an atom is the smallest unit of matter which takes part in a chemical reaction. Now there are certain contradictions of Dalton's atomic theory by the modern atomic theory. Now this is important for you to know, because at times in the examination it is asked how can you differentiate Dalton's theory with the modern atomic theory. So Dalton stated that atoms are indestructible, whereas modern theory states that atoms are destructible. It means they can be destroyed or they can be broken down. Then atoms are indivisible and the smallest particle of an element. Modern theory states that atoms are divisible. They consist of protons, electrons and neutrons. Then atoms of the same element are alike in all respect, whereas modern theory states that atoms of the same element may not be alike as seen in case of isotopes, because in isotopes we have different mass numbers, and that we'll study more in detail when we talk about the isotopes. Now we all know that there are 3 subatomic particles in the structure of the atom. We have electrons, and inside the nucleus we have the positively charged protons, and we have the neutral particles which are the neutrons. Now how these subatomic particles, the nucleus, the orbit, how they came into existence or how they were added up, what we have now the full structure of the atom, is the contribution of 4 scientists. Their names are important, and 4 discoveries that has eventually changed the science forever and has led to the structure of the atom. So one by one we are going to see. We need to understand the historical perspective of how these subatomic particles and the structure of the atom came into existence. So firstly, talking about the discovery of electrons, we need to know that William Crookes was the scientist who had discovered the cathode rays, and when the cathode rays were analyzed by J.J. Thomson, he drew the inference that these negatively charged particles are nothing but the electrons. So the experiment that was conducted was that a closed cathode ray tube or a discharge tube was taken, and these were, you can say, electric current was passed in this closed tube. A gas was taken at very low pressure. Okay, the positive end is called as the anode. This was the positive end, and this is the negative end, which is called as the cathode. So when electric current was passed in this discharge tube which had gas at very low pressure, it was observed that blue rays were seen emitted from the cathode or the negative end of the negative cathode, it was seen that blue rays were emitted and they were traveling from cathode towards the anode. So that was the simple experiment that was conducted by William Crookes. Now when these cathode rays, so he discovered cathode rays. Now when Thomson was analyzing these cathode rays, what he observed that these cathode rays had kinetic energy. So he also took the same setup, okay, and in this, when cathode rays were traveling, what he did, he placed an electric field over here, okay, a negative plate and a positive plate. So we know that cathode rays were coming out when electric current was passed. So these cathode rays were getting deflected towards the positive plate. So that was the observation he saw. Then he saw that the rays had kinetic energy. So these rays were having kinetic energy, and if an object is placed in the path, it was forming a shadow. The object was forming a shadow when it was placed in the path of the cathode rays. So the conclusion which J.J. Thomson gave was that cathode rays consists of negatively charged particles, which he called them as electrons. And his model, what he suggested, the model for the structure was called as the apple pie pudding model, where he showed that the negatively charged electrons are embedded in a positively charged sphere, and his model is also called as the apple pie pudding model. Okay. So that was the important contribution of William Crookes and Thomson. Williams discovered cathode rays, and J.J. Thomson, when he studied the characteristics of the cathode rays, he drew the conclusion that cathode rays are nothing but negatively charged particles called electrons. So now if I ask you which particles are negatively charged, yes, the answer is very simple. The negatively charged particles are the electrons. I hope you have understood. Now moving on to the discovery of protons. Now who discovered protons? It was Goldstein. Now obviously we say an atom is electrically neutral. If an atom is electrically neutral, it must contain some oppositely charged particle. He also conducted an experiment, and his experiment had you can say a modified cathode ray tube. In this modified cathode ray tube, he had placed a perforated cathode with holes. Okay, this was the anode, the positive end. This was the perforated cathode, and again electric current was passed. So what was observed? That a new type of rays were produced from the anode, which were passing through the perforated cathode. Okay, so these new rays, these were called as the positive rays. These new rays were seen coming out from the perforated cathode. So these positive rays were also called as the anode rays. Anode rays. And in the opposite direction towards the anode were the cathode rays. Okay, cathode rays were coming out. So the anode rays or positive rays consist of positively charged particles, and these charged particles were called as the protons. Okay, so the discovery of the positive particles led to the you can say discovery of the protons. So that was the contribution of Goldstein. Moving on to a very important discovery, that is the discovery of atomic nucleus, and this was done by Lord Rutherford or Ernest Rutherford. Now he studied the atomic model and he conducted one experiment. He took a very thin gold foil, and this gold foil he subjected to alpha rays. Now alpha rays are positively charged particles. So what were his observations when he carried out this experiment? His observations are very important. Firstly, he saw that most particles most particles passed straight. That is, the alpha rays were passing straight. Then secondly, he saw some got deflected, some deflected, and third observation was few bounced back. Few rays they bounced back. So that was his observation when he conducted this simple experiment. So if we see the gold foil in the form of a structure of an atom, what he was trying to say, that most of the particles pass straight, it means that most of the structure of the atom is hollow from inside. Some of the particles got deflected, it means some alpha particles went close towards the nucleus, so they showed some slight deflection. And those which were trying to pass through the core, that is the central core, that is the nucleus, they got deflected back or they bounced back. So through this experiment, he proved that atom on the whole is relatively empty. What were the important conclusion? That atoms are mostly empty. Atom is almost empty. Yes, atom is almost empty, and the dense core or the center is the nucleus. Dense center or the core is the nucleus, which is again concentrated with positive mass in the center. That is why it is leading to the deflection of alpha particles, because alpha particles are also positively charged. So when these positively charged particles are trying to enter the core, they are getting deflected because the central core is positive charge and it has a positive mass in the center. So that led to the discovery of a central positive region, which was called as the nucleus. Okay, so this was a very important contribution which was made by Rutherford and which eventually led to the discovery of the atomic nucleus. So if I ask you, why did some particles bounce back? Your answer will be the particles bounced back because those were alpha particles, and they were trying to, when they were trying to move towards the concentrative positive mass in the center, like charges, they repel. Hence, they were getting deflected due to, they were retracing their path or they were getting deflected by large angles because of the central core. The central core is having a positive mass. The positive mass was concentrated in the center. Okay, so that was the discovery of Lord Rutherford. He had discovered the central core, that was the positive mass in the center, which was called as the atomic nucleus. Moving on to the next, we have the discovery of the neutrons, and this was done by James Chadwick. He had studied the atomic nucleus, which led to the discovery of neutrons. Now we know that the electrons have negligible mass. Okay, electrons have negligible mass. So the mass of the atom should be equal to the mass of the protons. That was the concept, that the mass of the atom, that the atomic mass should be equal to the mass of the protons. But in case of helium, helium has 2 protons. It was seen that the mass of the protons was not equal to the atomic mass. That was seen in case of helium. Example we are taking of helium. So through this observation, it was concluded that there is something else present in the nucleus of the atom along with protons, which has no charge. No charge is there, but it has mass which is equal to the mass of protons, and these particles were called as the neutrons. Okay, so the mass was similar to the mass of the protons, it had no charge, and this led to the discovery of the neutrons. Okay, lastly, coming to the discovery which Bohr stated is the rotation of electrons around the nucleus. Now we know that the electrons are revolving in fixed circular orbits, and these orbits were called as energy levels or energy shells. and these energy levels or shells were, you can say, compared to the planetary movement of the planets around the sun. So this is called as a planetary model that was given by Bohr. So he stated that the electrons are revolving around the nucleus in fixed shells, and these shells were named as KLMN shell. So that was a contribution of energy levels or shells by the scientist Bohr. Later on in your higher grades, you will study more in detail about the contribution and about the various rules that have to be followed when we are writing the electronic configuration. That is for your higher grades. As of now, you need to know the name of the scientists and their contribution. Okay. So in this video, what we have discussed, we have seen the discoveries made by Goldstein. He had discovered the protons. Lord Rutherford discovered the nucleus. James Chadwick discovered neutrons, and electrons were discovered by J.J. Thomson. Now each discovery is very important because they are making up the whole structure of the atom. So now you know that it is not by one scientist who has given the structure of the atom, but 4 different scientists have given. So if we see in the structure of the atom, electrons, who has discovered? J.J. Thomson. Then in the core we have the protons and the neutrons. Protons was discovered by Goldstein. Then we have the neutrons discovered by James Chadwick. Then if we talk about this nucleus, this is the nucleus which has protons and neutrons. Nucleus was discovered by Lord Rutherford. So in one whole structure, we can see it is a contribution of 4 different scientists. So their contribution is very important, and you need to know how or which experiments were conducted in order to get the structure of the atom which we have it now. So in the next video, we'll be talking about the representation of an atom, how the atom is represented, and we will also see the first 20 elements and how to draw the structure of the first 20 elements of the periodic table. So please go through the lessons and go through the video again, and thank you for watching. We'll meet in the next video.